This is Physics 112, lecture 5, page 6. So I think probably I should write lecture 5, so you guys will know. All right, so we talk about Coulomb's law, and Coulomb's law tells you the magnitude of the force between two charges. So now we all know that force is a vector that has magnitude and direction. So now we haven't talked about directions, so let's talk about this. Let's suppose I have a positive charge and positive charge. Obviously they will repel each other. So the force of, let's say this is Q1, this is Q2, then the force of charge number 1 on charge number 2 will be acting in that direction. Let me call it F12. That is the force of charge number 1 acting on charge number 2. 1 on 2 is F12 in that direction. Similarly, F21, the force of charge number 2 acting on charge number 1 will be in that direction. Okay? So that's simple. And for unlike charges, they will attract, and the force that this is Q1, this is Q2, so that will be F12, that is the force of charge 1 on charge number 2 will be in that direction because this is positive, this is negative, so it's going to attract, so it's going to pull in that direction. Similarly, F21 will be in that direction. Okay, so these are, there are no complication because it's only, they are on one line, so then it's easy to think about. Okay, now we'll have to think a little bit more if we are working in 2 dimensions. Think about it. For example, let's suppose I have a positive charge here. Let's call it Q1. Another positive charge, let's say Q2 here. And then I put a negative charge somewhere here. Let's say a negative charge Q3. What would be the net force on Q3? What would be the direction of the net force on Q3? Of course, magnitude, we have to use Coulomb's law to find the magnitudes, but let's consider the direction. Well, this is positive charge, this is negative charge, so it's going to attract in that direction. It will pull, and this is positive, this is negative, so it will also pull in that direction. Depending on the distance and depending on the magnitude of the charges, then the magnitude of the forces will be different, right? So then we know that the net force on Q3 will go somewhere in between. Precisely, we'll have to, in order to tell precisely, we have to draw a parallelogram, then the net force will be in that direction. Correct? Okay? So that's how you will think about the direction of the forces. Just to make sure, let's do another example. Let's suppose you have a positive charge and a negative charge here. And then you have another positive charge in here. Let's suppose the distances are equal and the charges are equal. And then this positive and this positive, this is, let's call it Q1, this is Q2, and this is Q3, and Q1 is equal to Q2 is equal to Q3. The magnitudes are the same. The distances is, let's suppose this distance and this distance is also the same. Then what will happen? This is positive, this is positive. So the force of charge number 1 on charge number 3 will be in that direction. But this is negative, this is positive, so it will be in that direction. Right? So it will be in that direction. So what will happen is there will be 2 forces. One is this direction, one is this direction. So then we see that these 2 forces are going to act on this one, and the resultant force will be in the middle, right? So that will be the net force. F net will be in that direction. So that's how we think about forces on charges, all right? So the next one that we are going to consider is what we call electric field, all right? So why do we need to say something called electric field? Let's think about it. Electric field. So we talk about forces and forces acting instantaneously at a distance. So let's say like these two positive charges, for example, they are pushing each other. Why do they do that? Right? So then there is a little bit more fundamental concept called electric field. And the idea is this. If you have a positive charge, then there is something called electric field emanating from this positive charge in all directions, okay, radially outwards. So for a positive charge, electric field is outwards, right? So I'm not going to draw all, but actually it's going out in all directions, okay? And that electric field line will be continuous, but I don't want my line to be crooked, so I'm just drawing little arrows. But actually, electric field lines will be like this, all right? Not too bad. I was afraid that my lines are going to be crooked. All right. So for it's not only onto the right, it's in every direction, right? So in every direction, it will be like that. So for a negative charge, then the field lines, instead of going away from the charge, they'll be coming towards the charge, okay? So there'll be electric field lines like that. That is, for negative charge, you can think like all the field lines are pointing towards the negative charge coming into the to the charge. And for positive charge, then they are going out away from the charge, okay? So that's called electric field, and we denote it by E with the vector. That's electric field. This electric field has a formula. If you want to find the magnitude of electric field at a point a distance away, given a certain distance away from a charge, the formula is this. E magnitude will be kq by r squared. Okay? So it's very similar to the formula for the Coulomb's law, right? Just like the force between two charges. Actually, because electric force is k q1 q2 by r squared. Okay, so now just think about dividing this magnitude of force F by q2. So if I divide this means that is force per unit charge, right? And we can say that electric field is actually force per unit charge. So the unit of electric field, this should be, this is F, sorry. The unit for E, electric field E, will be Newton per Coulomb, because force is in newtons and Q is in Coulomb. Sorry, I messed up. This is just F, right? Okay. All right. So this electric field E can be interpreted as force per unit charge, all right? And it'll be given by newtons per Coulomb. So that will be the unit for electric field. and the direction of the electric field coming out from a positive charge will be away from the charge, and the direction of the electric field from a negative charge will be towards the charge. So that's all you have to remember. All right? Okay, so we'll stop here.